In this video, we're going to go over the top 10 subjects that you are most likely to encounter in a typical algebra course, whether you're taking it in high school, college, or at your local university. The first topic you will definitely encounter in algebra is linear equations. Here is what you need to master. You need to know how to graph linear equations, solve linear equations, find x and y intercepts, and calculate the slope between 2 points. You also need to understand parallel and perpendicular lines. Remember, parallel lines never intersect, and their slopes are identical. Perpendicular lines intersect at right angles, or 90 degrees, and their slopes are negative reciprocals of each other. The next major topic is absolute value. You need to know how to solve and graph absolute value equations. While linear equations produce straight lines, absolute value graphs form a distinctive V shape. The graph opens upward if the coefficient is positive, and opens downward if it's negative. Remember, the absolute value of any number represents distance, so it's always non-negative. Next up are inequalities. You need to know how to solve linear inequalities, compound inequalities, and absolute value inequalities. You also need to know how to graph your solutions on a number line. For example, if you have x is greater than 5, you plot an open circle at 5 because 5 is not included in the solution set, and then shade the line to the right. Next, we have quadratic equations. This is a major chapter in algebra, and you will spend a significant amount of time mastering it. You need to know how to graph parabolas, and how to solve quadratic equations using three primary methods: factoring, completing the square, and using the quadratic formula. You will definitely be using this formula extensively. How do you distinguish between a linear equation and a quadratic equation? It all comes down to the degree of the polynomial. A linear equation like y equals 2x plus 5 is a degree 1 polynomial. The variable x is raised to the first power. A quadratic equation like y equals 3x squared plus 4x minus 1 is a degree 2 polynomial. The variable x is raised to the second power. The next topic is solving systems of equations. A system consists of two or more equations work simultaneously. For example, consider the system 2x plus 3y equals 4 and 3x minus 5y equals 8. You can solve 2 by 2 systems using either the substitution method or the elimination method. You will also learn to solve 3 by 3 systems containing 3 variables, x, y, and z. Topic number 6 is polynomials. In this unit, you will add, subtract, multiply, divide, and graph polynomial functions. For example, you will multiply two trinomials like x squared plus 5x plus 8 times 2x squared plus 3x minus 9 by systematically distributing every single term. Next up, we have logarithms. You will learn to graph logarithmic and exponential functions, evaluate logarithms, expand log expressions, and condense them into a single logarithm. To understand logarithms intuitively, ask, to what power must I raise the base? Log base 4 of 16 equals 2 because 4 squared equals 16. Log base 2 of 8 equals 3 because 2 cubed equals 8. Log base 3 of 81 equals 4 because 3 to the fourth power equals 81. Topic number 8 is rational functions. A rational function features a variable in the denominator of a fraction, such as y equals 1 over x plus 2. When graphing rational functions, you must identify vertical asymptotes, where the denominator equals 0. Here, x equals negative 2, and the horizontal asymptotes, y equals 0. You will also add, subtract, multiply, and divide rational expressions by finding common denominators. Next, we have radical functions and expressions. You will work extensively with square roots and higher order radicals. To add expressions like square root of 18 plus square root of 50, simplify each radical first. Square root of 18 equals the square root of 9 times 2, which simplifies down to 3 square roots of 2. The square root of 50 equals the square root of 25 times 2, which simplifies down to 5 roots of 2. Since both terms share a common radical, square root of 2, add their coefficients just like adding 3x plus 5x. 3 roots of 2 plus 5 roots of 2 equals 8 roots of 2. And finally, topic number 10 is sequences and series. You will focus on two major types: arithmetic sequences and geometric sequences. In an arithmetic sequence, you add a common difference to reach each subsequent term. In a geometric sequence, you multiply by a common ratio to reach each subsequent term. You will learn to calculate the nth term and find the sum of the first n terms using summation formulas. Thank you for watching, and if you could, just leave a like, a comment, and subscribe. Thank you again. See you next time.